Okay, this is our first lesson on finding probabilities from the standard normal distribution table. Let's begin with a review of the 68, 95, 99.7 rule. Remember that what that tells us, if we have some data that's normally distributed, like this, we know that the mean of the data is right here below the center of the curve, the top of the curve. And I'm going to put the z-value for that point here. The z at the mean is 0. Remember, we get our z-value, what the z-score tells us is the distance that our data is above or below the mean. So if we're right at the mean, our distance from the mean is 0. If we go one standard deviation up above the mean, we're up here somewhere, so that's a z-score of 1. 1 meaning one standard deviation above the mean. If we go 2 standard deviations above the mean, we'll have a z-score of 2, and so on. So let me put z here to indicate that these values are in fact z-scores. If we go below the mean, over here, we have a z-score of -1. Going another standard deviation below the mean, we have a z-score of -2. And what the 68, 95, 99.7 rule does is it tells us, for instance, that the probability that we'll have a z in here somewhere between -1 and 1, that probability is 68%, or 68% of the data lies in there. So it's a probability, if we randomly selected one data value, we'd have a probability of 68% that it lies between -1 and 1 for its z-value. And then the probability of a z-score between -2 and 2, of course, is 95%. The probability of a z-score between -3 and 3 is 99.7%. Now, we saw how we could actually use this and calculate some other probabilities as well. So for instance, if we wanted the probability of a z-score below 1, so we want this part, but we also want to include what's over here, we might recognize that since there's 68% between -1 and 1, that means between 0 and 1 in here we have 34%, half of the 68. We know, of course, that from here over this is 50%. Okay, so the probability that z is less than 1 or less than or equal to 1, we can look at it either way because the probability of z being exactly 1 is 0. So the probability that z is less than or equal to 1 is 50% plus 34%, or 84%. Now, it's going to be handy for doing this kind of thing to develop a little bit of shorthand for writing this kind of thing. So this part right here we'll write a little bit differently. We'll say capital P for probability, and then in parentheses we'll put our condition on z. So we have z less than or equal to 1. So this says the probability that z is less than or equal to 1 is 84%. And as we saw before, we can find a number of probabilities from the normal distribution using just the 68% within one standard deviation, the 95% within 2, and the 99.7% within 3. But what if we wanted to find a probability that we're, say, between two z-scores that are not whole numbers? Then we need to have some more tools than what we have so far. And the main thing we're going to use to do that is something called a standard normal distribution table. So let's take a look at the table first. The table is going to come in two parts. We have one part that looks like this, and this part is what we use if we have z-scores that are greater than 0. So the z's are found over here on the left and across here on the top. Okay, so those are the z's where we find our z's. The left side gives us the ones place and tenths place for our z, and the numbers up at the top then give us the hundreds. And what we do is we go across where a row meets a column, and for instance this right here would be for a z-score of 0.43 if we're right here in this spot. Okay, so that's how we use the table. Now the other side of the table, the other piece, looks like this, and it's the piece where we have negative z-scores. You can see up here our z is to the left of 0 in this case. So let's start off, let's just go straight to an example. So let's say that we're interested in the probability that z is less than or equal to 1.63. Okay, so we want the probability that z is less than or equal to 1.63. So using our new notation, we can write that like this. Probability that z is less than or equal to 1.63. Now let's draw a picture of the distribution to see what we might expect for an answer. So here's our normal distribution, something like this. We have a z of 0 here in the middle. Up here somewhere would be a z of 1. Here would be a z of 2. And so the 1.63 lies in here somewhere. All right, so this would be where z equals 1.63. And what we're looking for is the probability that z is less than 1.63. So if we were to draw a line here, we want the probability that our z is over on this side. Now, what that corresponds to is the area under this curve, and that's actually what the standard normal distribution table gives us, is the area under the curve to the left of our z value. But that's also the probability that our z is less than or equal to that value. So suppose we have this z of 1.63 and we're trying to find the probability that z is less than or equal to that. So if we go to our table, we go down to the 1.6 row, which is right here. And then what we need to do is, if we look up the top, the 1.63, the 3 is in the hundredths place, so we need to go to this column for our hundredths place for our z. So if we follow down that column until we get to here where we're in the same row with 1.6, we can see there's our probability that we're looking for. It's 0.9484. So the probability that z is less than or equal to 1.63 is 0.9484, or as a percent we can write that as 94.84%. So the probability of getting a z-score less than or equal to 1.63 is 94.84%. Okay, let's try a different example where we have a negative value. So suppose now that we want the probability that z is less than or equal to, let's go with negative 0.48. Okay, so I just write this 0 in here to have a place to slide the decimal point in between. You don't have to put the 0 if you don't like to. So I want the probability that z is less than negative 0.48. Again, drawing our distribution like this. Remember, in the center we have a z of 0. These are our z's along here. And so negative 0.48, if this were negative 1, negative 0.48 is very close to negative 1/2. So that's going to be in here somewhere, that z is negative 0.48. And we're looking for the probability that z is less than that. So we're looking for the probability of being over here, or the area to the left of there. Now, of course, we know that the area to the left of 0 is 0.5, or that 50% of our probability is to the left. So this value certainly should be less than 50%, maybe even quite a bit less than 50%, 30, 40, 50, 30, 35, 40, something like that. So let's go to the table. And of course, this time, because we have a negative z, we need the side that has negative values for z. And we need 0.4 in the ones and tenths column, and then 8 or 0.08 in the hundredths column. So we go down here. Here's our negative 0.4. And you can't see the top of the table here, but you can look along on your own table. This column right here is the one that's below the 0.08. You can see I've already circled this value, knowing that that's the one we're looking for. So our probability is 0.3156. That's close to 30%, which is the kind of thing we were expecting. So again, the probability is 0.3156. Let's put that in here. And of course, that's equivalent to 31.56%. Okay? So that's how we find probabilities that z's are that we have a z less than or equal to some value. Let's do one last one. Let's have you try one. So in this case, let's look for the probability that z is less than or equal to negative 1.47. Why don't you give that a try? Pause the video because I'm about to give the solution. So again, you try that and then run the video once you've got your answer. Okay, so again, looking at the picture of the distribution, we've got something like this. Here's a z of 0. Negative 1.47 is even farther to the left than we were back here where we had the negative 0.48. So we're going to be quite a bit to the left on this one. So negative 1.47 might be over here. So we're going to expect a fairly small probability. This area over here is pretty small. So going to the table, going down the left side, we go down the left side to where our negative 1.4 is. We find the column on the top with the 0.07, and we find where those two meet. So if I come across in the negative 1.4 row, this is the column here that's below 0.07. And just by coincidence, pure coincidence, we have about 0.07 here as well. So this is our probability, 0.0708. So the probability that z is less than or equal to negative 1.47 is 0.0708, or 7.08%. Now that concludes our first lesson. What we've done in this lesson is we've learned how to find probabilities that z is less than or equal to some value using the standard normal distribution table. What we'll do in the next lesson is we'll go on to finding probabilities that z is greater than some value. So we might, for instance, want to know the probability of being up here, or we might also want to know the probability of a z lying between two values. So we might want to know the probability that we're in here. So those are the two things we'll do in the next lesson.